and welcome to the Rocketry of Virginia Tech 2019 first info session recording for those of you who weren't able to make it in person. My name is Johnny Jaffe. I am one of the co-captains for Rocketry of Virginia Tech, and I am a senior in aerospace engineering. So what we do, right here we have a video. We encourage you to check it out. This video is on our Facebook page. You can find our Facebook page by just searching Rocketry at Virginia Tech on Facebook. In addition, you can also find this video by going directly to YouTube and searching Rocketry at Virginia Tech, as well as a couple other videos. But it's a video from our 2017 Spaceport America Cup launch. So a little bit more about what we do. Over the past few years, we've attended the 2017 and 2018 Spaceport America Cup. For those of you who aren't familiar with the Spaceport America Cup it's an intercollegiate rocket engineering competition that is hosted in southern New Mexico, specifically at Spaceport America. The competition category we have competed in years prior is called 10,000 feet COTS. COTS meaning commercial off the shelf, which means generally a lot of the flight components we're able to buy. What separates us though in years past from a lot of other teams is we've done our own custom composite airframes, which are generally constructed out of carbon fiber with a foam core. In addition, for the last 2 years, our rockets have featured an active drag system for apogee control, which effectively includes flaps that deploy from the body of rocket to limit how high the rocket goes and get us closer to 10,000 feet. Each year prior, we've managed to keep our percent error within 1% of 10,000 feet. 2018, our rocket also featured a pretty unique flight system called rollerons, which are a form of passive roll stability. If you want to learn more on that, check out a Sidewinder missile. They also feature a pretty similar system. Each of those years, we've used a solid M-class rocket motor as well. And another thing to note about our past rockets is they've been built in a non-modular permanent construction, and what we really mean by that is that the main components of the rockets are epoxied in place with high strength epoxy such that they're non-removable. So that brings us to this current year, and this year is actually a continuation of a project we started last year between 2018 to 2019 semesters, and unlike years prior, we're in a different category for this launch vehicle, and that category is called 10,000 feet SRAD. SRAD standing for Student Research and Developed, which means that all the major flight systems of our rockets, not only do we design ourselves, but most of them we also manufacture. A unique system out this year is that it includes a hybrid rocket motor, and we'll talk a little bit about that later on in the slides. We're still featuring an active drag system for this year's rocket and continuing to refine that and improve it. This year's rocket carries a vibration isolation payload. It's a 3U CubeSat standard form payload, and we'll also talk a little bit about that more later on in this presentation. Other unique features of this year's launch vehicle include custom launch controller software. The team is continuing to expand. We have a new sub-team that was started last year that we're continuing to enhance, and that team is design validation, which focuses on engineering of views and simulation and really making sure that the launch vehicle has a lot of proper engineering analysis behind it. And another goal of this year is we're trying to get the majority of the team level 1 certifications with EEE. So now we've talked a little bit about what you will learn, or what we do at Rocketry. What we want to talk about as well is what you will learn and what you can expect to get out of this design team. One of the things that we really pride ourselves on is how the team approaches novel problems. Speaking for both myself and I think the majority of the members of this team, they'll tell you that a lot of us didn't have a lot of experience joining this team. I think most of us had little to no high-powered rocketry experience, but part of that process is that you take something unique, a problem that you may not have dealt with before, and we'll show you how to kind of approach problems like that. We have a variety of technical skills, all the way from software engineering up to composites manufacturing, and really an array of different technical skills. One of the things we are really trying to improve upon this year is system engineering processes. And a good example of that is we posted a figure on the right hand side of this slide, and that is actually taken from a senior design course taught here at Virginia Tech, specifically space vehicle design. So a lot of the stuff that we're working on with this year's team and how the team functions is really modeled after how senior design here at Virginia Tech works across most departments. So there's a lot of overlap there. We are definitely a fast-paced team environment, especially as we approach the end of the spring semester. So we'll teach you how to kind of work in fast-paced team environments that are relatively similar to a startup environment. And one of the biggest things that we really do that's unique to a lot of people is going from a concept to a finished product and working through how you get from point A all the way to point Z, essentially. And that's something that is unique for a lot of team members and really a cool process to go through. So we're just going to go over some of the sub-teams. So avionics and recovery. The sub-team lead for this is Park. Park's been with us for a few years now, great guy. And really what avionics and recovery is about, they work on telemetry, so how we stream data from the launch vehicle to the ground. Probably most importantly there, GPS data, so it can recover our rocket. Avionics and recovery works on the active drag system. They also work on flight data logging, which is very important for us when we cover our rocket to review that data. They manage an electronics bay within the rocket itself. They are responsible for the parachute selection, which is generally 2 parachutes, a drogue and a main. And as mentioned in the sub-team's name, they are responsible for recovering the rocket safely. So you can kind of see to the top right is a figure of what would be a mission ConOps for this rocket, basically the process that it goes through. The bottom left figure there is an old CAD rendering of an animation of an active drag system design, and to the right is a portion of the avionics electronics bay. And as Park says in his own words from 2018, the best team to be in, avionics sub-team, as well as I'll always choose avionics sub-team and will definitely recommend to a friend. And that's, you got Park's word on that one. Propulsion, the lead for propulsion this year is Danny. And this year is definitely an exciting year for propulsion. So their objective is to develop a hybrid propulsion system that is able to propel the rocket to 10,000 feet, which is no small task considering it's quite a large rocket this year. One of the things that they're working on this year is finishing the development of the hybrid motor. So we started some of the hybrid motor development last year, but it's still carrying on into this year. What really needs to occur for that is manufacturing systems and redesign of motor controller hardware. In addition, testing the motor and analyzing the performance. And to expand on that, we're looking to tentatively conduct cold flow testing this fall. Cold flow testing meaning that we have a liquid oxidizer in the tank that will flow and there won't be any combustion, it's just to test injector performance. And we're also hoping to static fire test in the spring. In addition to that, Danny is planning on beginning research and prototyping new systems. Those include active health monitoring and throttling. So this motor will allow us to throttle to change the thrust output, as well as looking into developing higher altitude capabilities. And some of the figures here in the top right include a hybrid rocket motor general layout. The reason they're called a hybrid rocket motor is it's a liquid oxidizer. In our case, that's nitrous oxide, and it's a solid fuel grain. That fuel grain is generally either ABS plastic or wax or a form of rubber. Rocketry at Virginia Tech is experimenting currently with 3D printed ABS as well as wax fuel grains. And the bottom picture there is a CAD rendering of the current hybrid rocket motor design. So payload as well is another sub-team. Each year our rocket carries a 3U standard form payload that weighs 8.8 pounds. The lead for payload is Colin. And the goal, develop a payload within the rocket to compete in the SDL Payload Challenge. That challenge is kind of an additional challenge included in our competition. Some of the constraints for that and requirements are to fit within a 10 by 10 by 30 centimeter space, i.e. 3U, and weigh more than 8.8 pounds. Until now, a new CubeSat structure was developed for each experiment. One of the goals of this year's is to reuse the actual structure itself each year. Previous payload involved shooting a small probe to gather data from the atmosphere. A picture of one of the tests of that is in the top left corner. We will also be completing the experiment, testing different methods for isolation vibrations. As I noted before, it's an isolation or vibration isolation payload, and there's two systems within that payload. One is passive, where we're using different materials with accelerometers mounted on them to test how well the material dampens vibrations. And the other is an active system, which is a voice coil actuator, which in one axis is designed to actually actively filter out vibrations from the vibration of the launch vehicle and aerodynamic stuff like that. And the last bullet there, begin working on an ejectable payload that can autonomously guide itself to a predetermined location. Some of you may recognize that bottom left figure is actually, I believe, a fairing from a Falcon 9. So that's another long-term project that payload is looking to work on as well. Aerostructures. So aerostructures, the sub-team lead for that is Trevor. The goals of aerostructure is to manufacture and improve the rocket's internal structure, work with composite materials for the airframe, perform structural analysis/testing, integrate other sub-team systems, analyze vehicle dynamics. They use a lot of software, which includes SolidWorks, MATLAB, OpenRocket, and ANSYS. Aerostructures is extremely hands-on with a lot of fabrication and manufacturing. They're responsible for designing and manufacturing effectively the entirety of the rocket, and as well as integrating and stacking vehicle prior to launch. So to the right there, we have two CAD renderings of the rocket itself. As we noted before in years past, the rocket is a non-modular construction which relies heavily on epoxy to fix components in their place. What's really unique about this year's launch vehicle is that there's an internal structure composed of aluminum square tubes that act as stringers wrapped around a carbon fiber composite skin. Unlike last year's rockets, there's really not a lot of epoxy used in this year's rockets. Most items are fastened in plates with bolts and nylon lock nuts. And what that allows for us is that if any components within the rocket body itself get damaged, we can actually replace that specific component relatively easy compared to actually using high-strength epoxy. Design validation. The lead for design validation is Peter. One of the goals of design validation is to provide feedback on the expected loadings and aerodynamic performance. So that really falls into two categories in order to actually complete that objective. Those include CFD and FEA. So for those of you who aren't familiar with CFD, that term stands for Computational Fluid Dynamics, which is a tool used to basically characterize flows. So those objectives include determining the drag coefficient of the rocket, validating that the rocket is stable, which is quite important, performing a flap study. That includes both the fins themselves to make sure that they're not going to flutter too much, which is a pretty common problem, as well as the flaps on the active drag system to see how they change the rocket's drag coefficient and stability. And CFD also includes design conditions in the nozzle themselves for propulsion, which is that image on the right-hand side of the screen. FEA, for those of you who aren't familiar, that stands for Finite Element Analysis, and the objectives of that include perform systematic study of the entire aluminum frame. So it's really trying to look to make sure that the frame can take the expected loading and it's not going to fail. And another objective includes supporting the propulsion sub-team by validating the reliability of the hybrid motor. Software. So the lead for software is Wade. Software works a lot with kind of every other sub-team on the rocket who have generally pretty strict or technically advanced software concerns and needs. So they're working on a few different projects at the moment. One that's quite important is a robust long-range Wi-Fi link between the controller and launch pad for command, control, and motor diagnostics. So effectively, when our vehicle is sitting on the pad, how we communicate to it. The top kind of right of this slide shows the proposed way that bridge and connection is going to work. Other projects include a custom motor controller software using robot operating system, or ROS as it's more commonly referred to. Um, Other software project includes estimation of vehicle position and velocity, integration of other onboard computers and sensor info and how we work with that data, and as well a general experts group. So as I mentioned before, software works with a lot of the other sub-teams to meet whatever requirements they have for pretty technically advanced software projects. So this is a new sub-team, Business and PR. The lead of that is currently, it's Will Lindsay, who is also the other co-captain for Rocketry Virginia Tech, or potentially if we find someone well suited for this sub-team and very interested in it, there may be another lead for that. And really what this sub-team is designed to do is to manage the budget, ledger, and allocations of about $20,000 or more in funding annually, hopefully more than that this year, as well as improve university outreach and general public outreach as well, PR and social media updates, logo, merch, and t-shirts as well. So some of the cool figures on this slide is top right is just our budget breakdown from years prior, specifically last year. You can kind of see where money is allocated towards. We actually have to do a lot of work ourselves for raising the funds for that budget from a variety of corporate sponsors as well as sponsors within the university. The bottom left picture there is from an outreach event where we worked with one of the local groups within the university to effectively introduce very young kids to rocketry. So that picture there actually shows a toddler, and we were working with stomp rockets, which is a lot of fun. And that picture on the bottom right was actually very recently. It was from this past ODU game where Rocketry Virginia Tech was invited to showcase in the President's Suite at Lane Stadium. And yeah, so we get a lot of exposure through stuff like that. So the application process, if you are interested in joining the team. Watching this is of course a good start to that process. The way it generally works is we're going to post a complete application or a link to our application on our Facebook page and our website. Once more, to find that application, we really recommend just go to Facebook, search Rocketry at Virginia Tech. It should pop up. We'll pin the application to the Facebook page. It's probably the easiest place to find it. We are asking that that application be submitted before midnight on Tuesday, September 17th. Really, applications after that we don't go through, so 12:01, we're probably not going to look at that. When you actually submit that, make sure you select which info session you attended, or if you have watched this video on the drop down menu for that. Be sure to submit your resume with your application, please. That's required. Once we get all the applications, the leadership for Rocketry Virginia Tech will spend time sorting through all those. From that, we will send out interview notices to people who are selected for interviews. Those interviews will take place between September 23rd to September 28th. When we send that email out, if you're selected for an interview, we will include sheets that go over the current roles that are open for the team. We ask that you select your top 3 roles, what you're most interested in. One thing we do like to stress is that those roles often evolve and change over the course of the year. However, we really use those selections to try to fit you to an area you think you will enjoy working with. And then we're trying to have all the decisions made by September 29th. And if you have any questions, we recommend that you email us. Our team email is rocketry.vt@gmail.com. We try to sort those emails as quick as possible and get back to you hopefully within a day. That doesn't always happen. At times we get quite a few emails at once, but we'll do our best to get back to you as quick as possible. And yeah.